this issue, I'm going to share with you how to build a Drosophila-inspired linear and nonlinear decision-making spiking neural network using our brain-inspired cognitive intelligence engine, BrainCog. It has been evidenced that vision-based decision-making in Drosophila consists of both simple perceptual linear decision and value-based nonlinear decision. When confronted with a choice task, Drosophila adaptively selects the appropriate pathway to make choices. The research team from Professor Guo studied the choice behavior and neural mechanisms of Drosophila when faced with a dilemma in a visual flight simulator. Drosophila flies first learn to prefer the upright green T pattern while the inverted blue T pattern is accompanied by a punishment. In the choice phase, Drosophila need to make choice between inverted green T and upright blue T to test their dilemma behavior under conflicting visual cues. It was found that the nonlinear pathway achieves an S-shaped choice curve. The neural mechanism supporting the nonlinear curve under the dilemma is the gain-gating choice mechanism, which is responsible for the dopaminergic neuron, GABAergic neuron, mushroom body, DA-GABA, and B loop. In contrast, Drosophila with damaged mushroom bodies will only perform simple perceptual choices, resulting in a linear choice curve. Based on the neural mechanisms of simple perceptual choice linear pathway and the value choice nonlinear pathway in Drosophila, we invoke the basic components in BrainCog to build a Drosophila-based inspired decision-making spiking neural network. The training phase uses a network learning process that integrates dopamine, long-term modulation, and local synaptic plasticity mechanisms, and the testing phase determines the choice of pathway and outputs the preferred behavior according to the task requirements. The linear pathway models the memory function of the central complex to make rapid choices. The nonlinear pathway models the DA, GAB, and B loop to implement the gain-gating mechanism. Specifically, the network structure of the nonlinear pathway is as follows. Visual information is transmitted from the compound eye to CAN cells, KC, in the mushroom body, and there is an interactive link between KC and APL. KC gives excitatory input to APL, and APL in turn inhibits KC. Mushroom body output neurons also receive excitatory input from KC and in turn output behavioral choices. When faced with a dilemma, conflicting visual cues lead to a physical increase in dopamine levels in the mushroom body that is maintained for 70 to 100 milliseconds. There is a bidirectional inhibitory effect between dopamine and APL, and dopamine also provides excitatory input to MBON. We implemented the Drosophila-inspired decision-making spiking neural network using the basic components in BrainCog. First, we use node, learning rule, and connection under base directory to construct the linear and nonlinear pathways by assigning neurons node to different subbrain regions. To construct the Drosophila linear and nonlinear decision-making spiking neural network, we define neural nodes to different subbrain regions, designing the connection matrix between different subbrain regions, and assign learning rules to the connections between subbrain regions. The training and the testing process of Drosophila-inspired decision-making spiking neural network is as follows. The training process uses a two-layer network for both linear and nonlinear pathways based on the reward-modulated STDP learning rules. And the testing process invokes the linear pathway and the nonlinear pathway for dilemma choice, respectively. The training phase learns that upright green T is safe and inverted blue T is penalized. And the testing phase makes the choice between inverted green T and upright blue T. The PI value at different color intensities are counted, and the closer the PI value to 1 indicates that the decision is very clear. This is a winner-takes-all decision. And if the PI value is similar to 0, It means that the selective behavior is uncertain and ambiguous. We test our model is implemented by BrainCog, and the results, we wait for it. From the results, we can find that the change of PI values for linear and nonlinear pathways with different color intensities, it can be seen that the nonlinear pathway can amplify the difference in the dilemma choice to make a winner-takes-all choice. If you are interested in our work, you can also welcome to set the following 2 articles, and you are also welcome to contact us by email. So that's it for today's introduction to Drosophila-inspired decision-making spiking neural network implemented by BrainCog. Thank you very much.